Welcome back to Mr. Yasuda's math videos. This video is going to be on the law of sines, and it's just going to be the basics. So if you're looking for anything kind of crazy or really specific to solving a certain kind of problem, this may not be the video for you. But this is just going to be the basics of the law of sines. What is it? When do you use it? And then how do we actually do a couple problems? And so let's get started. So what is the law of sines? When do you use the law of sines? So I've put two triangles here. And when you take a look at the two triangles, if you've been in a trig class for any length of time, or you've been in a unit using trigonometry for any length of time, you probably look at this first triangle over here and you say to yourself, I could solve for x and y, right? You've been given 27 degrees. It's a right triangle. And so you could probably say, okay, that's 27 degrees, x is my opposite, and 7 is my adjacent. So I could just use the tangent, right, of 27 degrees equals x over 7, and I could find x by multiplying by 7 and then using my calculator. I could also say that y is the hypotenuse, and so once again using 27 degrees, knowing the adjacent and knowing that I want to find the hypotenuse, I could use cosine. So cosine of 27 degrees equals, right, 7 over y. Then I can multiply by y, then divide by cosine of 27 and get my answer. So you can find x and y without any special law. So what makes that the way it is? It's because it's a right triangle. So if you have a right triangle, you're probably just going to use your basic trigonometry to solve for that triangle. However, the law of sines will allow us to solve for a triangle that looks like number 2 over here, because notice we don't have a right triangle. You've got 27 degrees here, you've got 33 degrees there. That adds up to 60 degrees, so this obtuse angle would be 120 degrees. So now we have a triangle that's not a right triangle, and the question lies, how would I actually find x and y? Because I can't go about finding x and y, because some of us might say, well, hey, draw a line down the middle, get yourself a height, turn it into two, right angles, and now you have two right triangles. Do something with that. Well, that'd be great if I knew how much this split it up, and it seems like a lot of work to actually go through to figure out how much of the 25 goes with the left side and the right side. So there's this thing called the law of sines that will allow us to solve for when triangles are not right triangles. Okay, so here it is, law of sines. Here's the big reveal. What is the law of sines? So the law of sines is as follows. It's just kind of this identity of what happens when you take the sine of an angle in the triangle over its opposite side equals the sine of B, that angle, over its opposite side, or you'll see this in your textbook, it'll look like sine of C over the side C. So you say, where are all these letters coming from? What's that look like? So let me just draw a triangle real quick. So let's call this A, B, and C. And opposite angle A will always be lowercase side A, opposite angle B will be lowercase side B, and opposite angle C would be lowercase side C. So the law of sines says that you can have this proportion where if you take the sine of an angle divided by its opposite side, it would be equivalent to the sine of another angle divided by its opposite side. When using I guess I should say this also, or you could go this way, whichever one's easiest. A over the sine of A would be equivalent to B over the sine of B, and C over the sine of C. When we're actually using the law of sines, we don't write a double equation like this. It's not going to be very helpful to solve. What you would do is you would say, okay, I want to use these two things, or maybe you want to use these two fractions, and you're just going to create a proportion. We should see one fraction when we're setting up our work equal to one fraction. We should not see multiple fractions set equal to each other. Now the question is how do you know which fraction to choose, well, usually you're going to be given 3 pieces of information, right? You're going to be given 3 pieces of information, and in this video and today in your work, you're either going to be given 2 angles, angle, angle, side, or angle, side, angle, and then you can go about actually finding the third angle and then finding the other sides using the law of sines, or you're going to be given 2 sides in order and then the angle that follows. You would not be given 2 sides that create an angle, but we will be given 2 sides and an angle. And so that's what you have, right? There will be more to be said about this scenario in my next video, but we'll save that for another day. All right, so law of sines seems kind of complicated. We haven't even done any math, but it's really not that bad, I promise you. So let's get going. So example 1, solve for the triangle ABC where angle C is 105 degrees, angle B is 40 degrees, and side C is 20 centimeters. So first thing I always tell people to do is draw a triangle if one is not provided. All right, so angle C, we'll call that obtuse angle, angle C, because it's 105 degrees. Call this one angle B, which leaves this to be angle A. Angle B is 40 degrees. And we're told side C is 20 centimeters. So side C is always across from angle C. So we've got our picture. Second thing we're going to do, right, is we are going to find the third angle before we do anything. If you're given 2 angles of a triangle, you should always be able to find the third angle. All right, so I'm going to set up my answers too. I like to just kind of be really thorough. So angle A would equal angle B equals angle C equals, and then side A equals side B equals, and side C equals. I just like to kind of have nice work so I can just list everything once I've got it. So angle A, if we take 105 plus 40, that's 145. So angle A is going to have to be 35 degrees if it's going to add up to 180. All right, 105 degrees, and then that's 20 centimeters. All right, now that we know our third angle, right, is 35, we're going to be able to solve for the triangle. Remember, solving for the triangle means you have to find all angles, which we've done, and now you have to find all sides. So we're looking for side A, and we're looking for side B. This is where the law of sines is going to come into play. We're going to set up a proportion, all right, and you've got to think about this. You want to solve an equation. So your proportion, right, using the law of sines, so your proportion can only really have one variable in it, because then that's what you're going to solve for, right? So with that said, I'm going to take and I'm going to solve for A, okay? So I'm going to take the opposite angle, sine of 35 degrees, divided by A. That's my unknown. Now, that's my unknown, so that means my next fraction, right, because we're going to have one fraction equal to another fraction. Sorry, I had to hit pause for a second. I have no clue what I was saying before that. Somebody had to come in and ask me some stuff. So anyway, you've got this proportion that you're setting up, and you really need only one variable. So one of your proportions has to be a full fraction, or you have to know both an angle and an opposite side. So I'm going to go with the information that I learned on side C, or angle C and side C. That's what was given. So sine of 105, right, and then over 20. So if you look at this fraction that I've set up, or this proportion I've set up, all the information I know except side A. So that's my only variable. I'm going to set up another one for B. I'm going to use the same thing, sine of 105 over 20 equals, right? And then for B, we want to go with the angle, sine of 40. degrees over side B. And so you can see that each fraction or each proportion only has one variable. And now you can solve each by cross multiplying and dividing. And so if we're taking a look, we would do A times the sine of 105 equals 20 sine of 35. And then A would equal 20 times the sine of 35 over the sine of 105, divided by the sine of 105 on both sides. And then you can put it into your calculator. Just make sure your calculator is in degrees, and you should get A is roughly 11.88 centimeters. Then we can do the same thing on the other side for B. And so you would get 20 sine of 40 degrees equals B sine of 105 degrees. Divide, and so B would equal 20 sine of 40 over sine of 105. Alright, make sure your calculator is in degrees, and you should get that B is approximately 13.31 centimeters. And so A is 11.88 centimeters, and B is 13.31 centimeters. Before we move on to the next problem, I want to point out just one thing in regards to triangles. And I know, geometry may not have been your favorite, so let me give you just a quick clue as to how you know that you did it right. Okay, so here's one check that you can use. First, when you look at the angle and its opposite side, you should remember that the smallest angle should always be across from the smallest side. The biggest angle across from the biggest side, and the middle angle, right, the second biggest, should be across from the second biggest side. Also, another check you can do is remember, when you add two sides of a triangle together, that should always be bigger than the largest side. So if you take 11 plus 13, it's 24, and so that's bigger than 20. So obviously, we have ourselves a good triangle. All right, let's do one more, because in this one, you're given two sides and only one angle. So we're going to have to do a few different calculations in our calculator. All right, so I'm going to draw a picture. So here we go. I'll call that A, call this B, call this C. A is 75 degrees. Okay, B is 33.7 inches. A is 51.2 inches. So as you can see, we've been given two sides, right? Two sides in a row, and then the angle that follows. And so this scenario, I'll touch more on it in the next video, but what we want to see is that in this scenario, you're actually missing two angles. So angle A obviously is 75 degrees. Angle B, don't know it. Angle C, don't know it. We know side A is 51.2, right? And side B is 33.7. But we're missing side C. If you take a look at this, right, you can't even talk about side C or angle C because you don't know either of them. And so you really have to find the only angle that you can find. And the only angle that you can find right now in this scenario is side B, or angle B, because you know one angle and you know its opposite side. So that gives you a full fraction, sine of 75 over 51.2 equals, and we don't know B. That's what we want to find, sine of B over 33.7. And so notice my equation, right? You want to find the angle that you can. Right? Can't find C at all. It's not even an option. And I can only find B. And so now B is my variable. And notice that it's an angle inside this sine function, right? It's trapped inside here. So what am I going to have to use? I'm going to have to use an inverse function in order to figure out angle B. But first, what we're going to do is we're going to get the sine of B alone. Okay, so I need to get this alone. I'm not going to cross multiply because sine of b is on top, but I am going to multiply by 33.7 on both sides. That way they'll cancel out here, and then I'll have 33.7 over the sine of 75, or times the sine of 75, over 51.2, and that will equal the sine of b. It's not going to equal b, right? It's the sine of b. Now, in order to figure out what b is, we're going to use the inverse function. So I'm actually going to take the inverse function of the other side, and that's what b will equal. So the inverse sine of 33.7 times the sine of 75 over 51.2 is going to equal b. That is how we're going to find b. Make sure your calculator is in degrees, and once you have that, you'll find, right, you can put that whole thing into your calculator, and b should equal roughly 39.48 degrees. All right, and so now when you think about it, okay, 39.48, how does that impact me? Well, now I know two angles, and I can add them together, and I can find the missing angle, and by subtracting from 180 after I add them together, and that should get you 65.52 degrees. Now that you know angle C, you can find side C by using the law of sines. If you want to hit pause, go ahead and find side C on your own. Set up the proportion correctly. I'm going to use the original information given to me because I feel like that gets me a better and more exact answer. I'm not going to use angle B and side B because I rounded angle B. So here we go. I'm going to set it up. Sine of 75 over 51.2 equals the sine of 65.52 over side C. So if I multiply, right, cross multiply of C times sine of 75 equals 51.2, sine of 65.52, so C will equal 51.2 sine of 65.52 all over sine of 75. And if you put that into your calculator, make sure you're in degrees again. C should equal 48.24 inches. I'm just going to run through my checks again. Largest angle is across from the largest side. That makes sense. That lines up. Smallest angle is across from the smallest side. I'm feeling good about this triangle. All right, that's the law of sines. Hopefully it makes sense. Should be good to go from there. And best of luck. Have a great day.